Attention, please. The train for Jerusalem will be leaving in 2 minutes. Bon voyage. The Israel railways are modernizing the track. The old rails are going. The new rails are continuously welded. No more gaps and joints. No clickety-clack of jogging wheels and swaying coaches. Ladies and gentlemen, you will feel the difference between travel on the old and the new track. This film will show you our Operation Change Rails. The conventional track.
The rails are on wooden sleepers with regular gaps.
The new track.
Concrete sleepers, long welded rails and no joints.
The joint.
Each joint causes some jolting. On the old track there is a joint every 18 meters. Tomorrow a continuously welded track. No more gaps, no more joints. Thousands of meters of track without a single joint.
Until now,
the track consisted of a layer of ballast, wooden sleepers and rails fastened to them with dog spikes.
Today,
ballast, concrete sleepers and rails tightly secured to them by bolts. The wooden sleepers must be imported and wear out quickly. The concrete sleeper is made in Israel and lasts longer.
Mr. Arnold Bagon, the Belgian engineer, developed the system. His concrete sleeper has all the advantages of old wooden sleeper, but is stronger, lasts much longer.
Between sleeper and rail, a special rubber pad is placed to provide elasticity and insulation for the electric signaling. Locally made bolts replace the imported spikes for fastening the rail to its sleepers.
These concrete sleepers are made at the Yuval Gad works.
The sleeper is cast in 3 separate sections, joined and held together by steel wires that are post-stressed with a force of 17 tons.
The Yuval Gad plant turns out some 300 concrete sleepers a day. 150,000 will be needed for the Haifa-Tel Aviv line.
The 3-section design of the sleeper gives it the elasticity that is vital on the railroad. No effort is spared to assure the sleeper's high standard. Here the wires are threaded, the sleeper is stressed, tarred and sealed. The sleeper is now ready.
Yes, ready, but
before it is checked out, it must first go through a series of tests for strength and durability. Only then will it be passed as fit for service.
Haifa.
Here, panels each 18 meters long are assembled, panel after panel. Each panel has 30 sleepers, and they are placed at a distance of exactly 60 centimeters center to center. On a rail line, every centimeter counts, and all measurements must be precise. This precision will give the track its stability and assure the smooth running of the trains. A few turns and the bolts are tight, fastening the rail securely to its sleeper. The old dog spike has made way for the bolt. From here, the ready-made panels are transported to the work site.
On the site. The trains have been running on this line for over 40 years. Now the old track must retire and make way for the new track.
But the changeover is not quite so simple. After the old panels are removed, the ballast must be leveled. A simple mechanical scarifier does the job. Next, the portal cranes move up and down and put new panels in place. A fresh layer of ballast is added, spread and tamped, and the track is ready for traffic. The new rails alongside the track are welded together into a single continuous track.
No more jolting. We know that steel expands and contracts with temperature changes. Are the gaps we've been used to on the track not necessary?
No, the rail's expansion and contraction are reduced to a minimum, because the welded rails are fastened to the sleepers at neutral temperatures. The stresses that still occur are braked by the tight bolts and the friction between sleeper and ballast.
The welding.
Before they are welded together, the rails are leveled and adjusted into a continuous straight line. For the welding process, molds are fitted to the ends of the rails. The rail's ends are preheated to a temperature of 1,200 degrees centigrade. Then the thermit is lit and cast into the mold. When the weld sets, the mold is removed and the jagged edges are ground and smoothed down until no traces of the weld remain. Now it's just as though there were no joints at all.
Next stage.
Now that the roadbed has set, the temporary rail has also finished its job. It's removed again, and the long welded rail is placed on the sleeper. Then it is bolted down and is ready.
Not quite.
No, not quite yet. The final tightening of the bolts must wait for the right neutral temperature of between 28 and 38 degrees centigrade on this particular section to prevent excessive expansion and contraction in future. The stresses are eased out. Now we must hurry, because very soon the temperature will be too high. This time the rail has been fastened to the sleepers for good.
And now?
And now the track is finally tamped and leveled. This sophisticated machine does several jobs at once. It moves along the track from sleeper to sleeper, levels the rails and tamps the ballast. It works automatically and with a high degree of precision.
And now at last.
One more machine, the track liner, which adjusts the track into its exact position. The track liner pays out a wire, and wherever the rail deviates from the straight path, a gauge shows up the error. The liner's hammers put the rail back into its straight line, and the track is ready.
The track is ready.
The reconditioning of the track and replacement of the rails has been completed on the Haifa-Netanya section, and the new track is ready for traffic of passenger and goods trains. work continues, and every day a new section is completed. For many years, the old track carried Israel's trains, but now the new track takes over.
Bon voyage to you all on the new track.
The end.